The broadcast is now starting. All attendees are in listen-only mode.
Hello everybody and welcome to the second of our March webinars. Today we have a webinar with Jeffrey Payne called Continuous Everything. And if you have any questions about the webinar, if you want to pick Jeffrey's brains about any of the particular information he's going to be sharing, you can type your questions into the questions field on your control panel. And at the very end of the webinar, then we'll come back to them and go through them one by one. And just remember as well, you don't have to wait until the very end of the webinar to start typing your questions. Just type them in as you see free, and we will address them at the very end. Okay, so I'm now going to hand you over to today's presenter, Jeff. Hi, Jeff.
Hey, Daryl, how you doing?
Great, great. So Jeff is just going to open his screen here now, and we're good to go.
Great. Well, thank you very much. I'm happy to be here today. The talk is called Continuous Everything. And for those of you not familiar with myself or Coveris, my company helps organizations improve the agility and security of their applications, their teams, and their enterprises. We do that by helping companies go through a transformation to agile. We do DevOps implementations. We help companies build and test security critical apps. And we provide coaching and training services to a wide variety of companies. If you want to follow me on Twitter, my address is Jeffrey E. Payne. And I do tweet quite a bit, so if you're interested in the topics of Agile, DevOps, security, how they all integrate together, please check it out on Twitter. So I call this talk Continuous Everything because essentially I believe that if we're doing things right, almost everything we do in Agile is continuous. Continuous planning, continuous integration, continuous testing, continuous security, continuous improvement. You hear the word continuous all the time in Agile. And what I wanted to do in this talk is talk a little bit about what the benefits are of operating in a continuous manner, go through some of the enablers in an Agile process for being continuous and becoming more continuous, and then talking about how you can move your process toward a more continuous process so you can take advantage of some of those things in an Agile process. So that's what we're going to cover here today. So I thought I'd start at the top with the definition of continuous. And there's a couple definitions I looked up that I thought were interesting. The first was that continuous is forming an unbroken whole. It's something you do without interruption. It literally means doing it again and again and again and fluidly throughout time. It also, interestingly, is another term for progress. If you're doing things continuously, you are often making progress on something. And we'll talk a lot about that when we talk about the benefits of being continuous. But the word continuous also has a lot of synonyms. These are some of them that I noticed. Unceasing, nonstop, around the clock, perpetual, unending, unrelieved, relentless, unremitting. A lot of synonyms that all mean these same fundamental things. Doing things without interruption, making progress, forming an unbroken whole. And I guess it should be no surprise that in Agile we think about things in terms of continuous activities, because if you look at the principles of Agile from the manifesto, you'll see the word continuous and its synonyms all throughout its principles. I've highlighted some of those by bolding and underlining them within some of the principles of Agile that you see in the manifesto. You'll see things like continuous attention to details, measuring progress. At regular intervals we do things, doing things early and continuously, welcoming change regularly, preferring shorter time scales, maintaining constant pace, working together daily. All these, again, are synonyms for trying to do things in a continual manner. Now you'll notice that one of the synonyms for the word continuous is perpetual. And I thought a great analogy to use for what we're trying to do in Agile from a continuous perspective is represented in this little GIF that I have running here. This is a perpetual motion machine, supposedly, right? A perpetual motion machine is perpetual motion is motion that continues indefinitely without any external source of energy. Now, the goal of identifying and creating perpetual motion machines has been around for centuries, if not longer. Man has always tried to figure out, how can I build a machine that operates by itself? Once it gets going, it never stops and it never needs any external source of any kind of energy. And of course, we know from the laws of physics and the laws of science that we have created as a mankind that our current understanding is this isn't possible to do. And there's been many examples and attempts at making things continuous and perpetual in the physical world, and no one has ever figured out how to do it. This GIF is obviously cheating. It's resetting as it goes around. And actually, this machine, there are some examples of machines out there that will go for quite a while. They're tuned to be frictionless as much as possible, and they're optimized so that they go quite a while on their own, but they will eventually stop. I thought perpetual motion would be a good theme to put throughout this talk, as it really gets to the concept of what we want our agile process to be, something that continually moves and continually makes progress without ideally any external source of energy. The team itself is the energy, and it figures out how to keep the process going. So let's talk about some of the benefits of doing continuous everything, as I call it. What does it give us? There's 5 different things that I want to talk through briefly that continuous energy and doing things in a continuous manner give us. It gives us rapid feedback, gives us the ability to embrace change, gives us ongoing and regular customer value, it allows us to practice, and it gives us confidence for delivery. On the right here, I have one example of an attempt to make a perpetual motion machine. This is called a water screw, and it was designed and defined in 1816. And the idea behind it is pretty simple. For forever, man has used water to power mills and to power operations and activities. But the problem is that you need to be somewhere near a constant source of water. The idea behind the water screw was, what if we could invent a machine that powers itself? And so on the far right is a water wheel that takes water from the top, and it turns as water pours into it, and that turns an axle which is hooked to a couple of gears, which in theory does a couple of things. On the far left, it turns a mill grinder, so we can grind flour and other things to produce food. In the middle, we have a pump, and the idea is that as the pump rotates, as the axle moves and the gear makes it turn, that the water is pumped back up to the top and then flows back over the water wheel. You'll see another example of this concept a little bit later, but that's how, in theory, it's supposed to work. So let's talk about what continuous everything gives us that helps us from a customer and a benefits perspective. The first is rapid feedback. So the Agile mantra is we want to fail fast, right? If there's something wrong with our software, if there's something wrong with our process, if there's something wrong with our understanding of the requirements or whatever it might be, we want to find that out as early as possible in the process. Fail fast is a critical concept in Agile. We know we're going to do things wrong. We're not going to be perfect. When we find a problem, we want to find it quickly. There's a couple reasons why we want to do that. What does rapid feedback give us from a business perspective? Well, the first thing is that, in general, people learn more from failure than success, right? When I do something successfully, I don't think much about it. I just go, oh, great, I did it successfully. That's awesome. I'm very happy about that, and I move on. If something doesn't work, that's when I stop and say, why did that work? I don't want that to happen again. That was painful. What can I do differently next time so that it works? So we learn a lot from failure. And the more rapid the feedback is and the faster we fail, the faster we learn, essentially, if we're paying attention. And that means we can improve a lot quicker and grow our capability a lot faster. course, the other thing is the downstream activities. When we find out downstream in our software development process, so for instance, as we move code into various testing stages and then into production, as we move down that process and we find problems, it's often very costly and it results in a lot of rework if we don't find things quickly that are wrong. And so our goal is to push as many of our downstream activities as possible earlier into our agile process so that we find those problems quicker and faster and easier, and we reduce the rework that we have in the process itself. The second is our ability to embrace change. In a Fundamentals of Agile course that I give and we give at Coveris, we talk a lot about the Agile bet. And the Agile bet is really this statement. If the cost of change can be kept low over time, the cost savings that result from early feedback will far outweigh the added cost of early change. What that essentially means is if we can keep the cost of changing our minds, and let's face it, everybody changes their minds, including our customers, if we can keep that cost low so that we don't have a lot of rework when we change our minds, the savings that we get from not having to do that rework later in the process makes it affordable for us to be able to change our minds more regularly and still stay in budget and time constraints. That's the Agile bet, and it's all about embracing change. One thing I've learned is that the concept that we had in the early days of software engineering and software development, the traditional kind of software development approach where we tried to fix and define our requirements up front, didn't work very well. And we didn't try to embrace change. We tried to freeze change, right? We tried to freeze requirements, freeze code, freeze design as we marched through the process. We tried to gold plate those requirements. We spent an incredible amount of money and effort trying to define requirements that we were sure were perfect so we didn't have to change. Change was expensive, change was late in the process, and change resulted in a lot of rework. But guess what? The world changes every day, right? Today more so than decades ago. Technology changes, competitive landscape changes, technologies available to us change. All these things are changing constantly, and so Agile recognizes that, you know what, we can't control change. We have to figure out how to embrace it and deal with it in a low-cost manner. Now, one of the big things that we need to talk about in terms of change has to do with how we deal with customers. Agile is really big on giving ongoing customer value, and we do that as continuous as we can. One of the reasons why it's hard to fix requirements is that customers actually don't know what they want until they see it. That's a really big problem for traditional software development processes that don't actually produce any code, anything to see until late in the process. Because what that means is basically you don't know if your requirements are right until you spent maybe 9 to 12 months working on something. And customers don't know what they want until they see it. And so you're going to have a huge amount of rework in that model. If we can shorten the time between when we work with customers and representatives of customers to understand what they want, and then show them what it is that we think they want, and they can give us feedback, then we're going to be able to fail fast and rapidly fix problems, and it's not going to cost us a lot of money. Now, some people will say, well, gosh, we've been doing that forever. That's called rapid prototyping. That's not the same thing, all right? I did rapid prototyping 15, 20 years ago, and when I first learned about rapid prototyping, I thought it was a great approach, and it is good in a traditional environment where you have to work in a waterfall model or a traditional process. Rapid prototyping is a valuable thing because basically you're mocking things up and you're showing customer what the requirements are going to look like. That's the great thing about rapid prototyping. The problem with rapid prototyping is oftentimes what I found was once I would show it to the customer or to my boss would say, great, ship it. And I go, well, I don't really have any software yet. And he's like, well, what do you mean? I'm looking at it. Well, now you're looking at a prototype, a mock. Well, just, test it up and let's put it out the door. Those were the kind of challenges that you had with rapid prototyping, because management didn't understand that what I was showing them was smoke and mirrors. It was a pretty display with not a lot of capability underneath it. Agile really took that concept, I believe, and drove it into this idea of we're going to build working code on a regular basis. We're going to use the advantages of prototyping, putting something in front of our customers so they can give us their view of whether the requirements are really what they want, but that we do invest a little bit in building that to be working software on very short increments, so that if they say that's what they want, that piece of the software is done and it's ready to ship. We'll talk about releasing and shipping in a bit. This does allow us then to move the release of software to a business decision instead of a technical decision. Now the IT or software organization isn't defining when the software is ready for release, right? We don't have to get through a series of phases to say, well, it's done with testing, now it's ready for release. We're building and testing it as we go, and at any time the business can say, you know what, I'm going to make a business decision to enter an endgame process, enter a release process, and get what I have out the door as the next release. Releasing software should be a business process and a business decision, and Agile, for doing things continually, lets us do that. It also lets us focus on a minimum viable product and get something out the door as fast as possible. A lot of times I work with a lot of big companies and startups are really big on, look, we don't have a lot of money, we've got to focus that money, and the key thing is to get to first customer. We need to get to customer, and that means we need to understand what the most important things are that a customer base will want and deliver a minimum set of those requirements that make the customer happy, and deliver it as fast as we can so we can get customers and hopefully, of course, go get more money. But the same thing applies to a large company who's rolling out a new product or a new capability. Why build something that's humongous and massive until we really know what the customer wants? The next capability enabler is practice. I don't know who said practice makes perfect, but you hear that quote all the time, right? Another quote you hear a lot is attributed to Vince Lombardi, and it's practice does not make perfect. Perfect practice makes perfect, meaning if you're not practicing in the right way, you're probably not getting better. I also like a quote that Thomas Edison says. He used to say, I don't fail. I just find 10,000 ways something doesn't work. There's stories about how many times he tried different approaches to the light bulb before he actually got it to work. And it's in the tens of thousands, or at least in the thousands. The idea of practice is that the more we do something, whatever that is, and if we do it repeatedly, continuously, and early, it increases our confidence by the time we get ready to release software. So let's take testing, for instance. If we don't do any performance testing until we're right before release, we will not have practiced it enough to be good at it. And by the way, late in the life cycle, we're going to find out that we have problems and we've violated the concept of failing fast. So by doing things earlier and continuously and repeatedly, we're practicing them to the point when we're ready to do those activities. Even if we can't finish them until late in the life cycle, we've done it enough times on subsystems of what we have that doing them one more time is no big deal. We know how long it's going to take, and we're ready for it, and we know how to do it successfully. No more so is that important than when we talk about delivery, right? Releasing software. I've been involved in a lot of delivery practices and processes, and what I typically see out there is this. So first of all, release is a scary word, right? When you say the word release, everybody's eyes light up, everybody starts chewing on their fingernails, and everybody starts getting nervous because releases often don't work. That's one of the reasons why when we release, we often ask the release team to do it in the middle of the night or over a weekend or some horribly inconvenient time, because that's when our customers potentially aren't using our software. That's really, quote, downtime, and a time when we feel like if we release it and it doesn't work, it gives us time to scramble, figure out what's wrong with it, and make it work right. All right, that's a horrible process. In fact, what you want to get to is the point where you're delivering and releasing software, at least internally, so frequently that release isn't a scary thing. You've practiced it, and you've gained confidence that the release is going to work. That's why in a DevOps world, we like to think about what we call releasable software candidates. Every time we check in code, ideally, we'd like to create a new working integrated version of the software that is a release candidate. That doesn't mean we're going to release it to production. That's a business decision. But it means that it is ready for us to push through the process, hopefully automatically. We'll talk about DevOps in a bit, and get it out the door and make it work. The more confidence we can have every time we check in code that we have something that is releasable means we gain significant confidence when the business says it's time to release, that our release process is going to work and we're going to be successful putting it out to our customers. So it gives us confidence in delivery. I would ask you this question. In our traditional approaches, how much confidence do you have when we do the following things? When we integrate software late in the life cycle for the first time. I can tell you I got involved in a project that was a 12-month project. We got involved 6 months into it. It was a traditional software development process. This was years ago. And the team that was working on this had never integrated the code. They had allocated 2 weeks at the end of their software development process to do, quote, integration. And when I talked to the project manager about this, I said, do you really think that after a whole year of building an application and none of that software has ever been integrated together, that you're going to successfully integrate it and get it out the door in 2 weeks? And he said, oh yeah, it shouldn't be a problem, right? It doesn't take very long to compile the code. Now, I knew right then we were in trouble because there was just no way, if his understanding of integration was get through compilation, that he really understood what it was going to take to get the software out the door. Now, when I give this example in the fundamentals class and other talks, I always ask the audience, how long do you think it would take, right? And people throw out all sorts of answers, 4 weeks or 8 weeks. I've had people say 10 years. They were kidding, but hey, you never know. In the end, it took 6 months for that software to integrate successfully when they got to that 2-week step. If you don't start test execution until all the code has been frozen, how confident are you that you've got a viable candidate? You've never tested it and you're all the way at freezing code for the entire system. How confident are you that if you build software based on requirements that were defined maybe a year ago, when the world is changing every day and your customer doesn't even know what they want until they see it, that you've built the right thing? And then last but not least, how confident are you if you've never deployed your software and tested it on any environment that looks like production? I'm not saying it's exactly the same as production, but we would call it production-like. You're not doing that until the time right before you actually launch the product. How confident are you? Now, like most of you, if you're experienced, I look at these things and I say, gosh, these are root causes of failure. When I see these things, and when I come in and are assessing someone's software development process and trying to help them become more agile, I know why they're struggling. Because these are things that if you do, you're not going to successfully put out software and have confidence in your delivery. So let's talk about the enablers of continuous everything. How can you make this process better? And I'm going to focus on 4 of them. 2 of them are technical and 2 of them are social, i.e. Cultural, right? Because one of the things I've seen and learned is that, there's all sorts of tools and technologies and approaches to make things better and faster and enable things in Agile, just like in any process. But it's change, and change is hard, and people don't just magically change overnight. And so a lot of the time we spend in the Agile transformations that we do at Coveris are spent on change management, and helping people move toward doing things in a different way. If you don't help people change and figure out how to get them to work together differently, they're probably going to revert back to the way they used to do it. Intuitively, to me, it makes no sense that if something didn't work and you try something new and it's hard, that you would go back to the thing you know doesn't work. But that's human nature. It's safe, it's comfortable, at least I'm not uncomfortable. I'll go back to the way it was, and I'll just deal with it then. So let's talk about these: automation, virtualization, collaboration, and being agile. The first one is automation. Not automating activities in your agile process are only going to get you so far in your agile journey. All right, you cannot successfully do agile as your software grows without leveraging automation. I'm talking about build automation, I'm talking about test automation, I'm talking about continuous integration, continuous delivery, and deployment. Initially, you can probably get away with doing some of that or even all of that manually, and you might make some good progress, but you will eventually bog down. And the reason is that I always equate Agile to a Russian doll. Let's take testing, for example. Right, when we start a greenfield new project, we don't have any code. So the first sprint that we follow, if we're following Scrum, we have some code. And so the test team, as part of that process, is involved, and they're testing that code. And all the testing they're doing is against new code. So they're just testing whether the functionality of the code meets the acceptance criteria of the stories and the use cases and business case and acceptance by the customer, right? Great. Second sprint, we now have new code that needs to be tested to make sure it works as specified. But we also now have to make sure that new code integrates with the old code successfully. And then we need to regression test that the new code didn't break the old code. Great, so we do that. The third sprint, now we have new code, and we need to do the same thing. Test it, make sure it works, make sure it integrates now with 2 sprints worth of code, and then regression test everything that we have to make sure it didn't break something. A Russian doll is a doll where you can crack it open and it gets smaller and smaller and smaller, and when you put it together it gets bigger and bigger and bigger. Agile, your software grows over time. It is an incremental approach to building software, and so you're going to have more and more and more software over time. That means your testing is going to get harder, your integration is going to get harder, your delivery and deployments are going to get harder, and you'll be able to do those things manually for a while, but as the doll grows, you will run out of time. And that's why often I see test teams that are pulled out of sprints and they're made later in the process. I see sprints going on with parallel activities where development is focusing on the new stuff and testers are focusing on the old stuff. All we're doing when we do that is lapsing away from being continuous. We're moving back into putting these things into phases, right? Design in a phase, development in a phase, test in a phase, and we're elongating the customer feedback. We're elongating our ability to fail fast. We're elongating our ability to embrace change and change things without significant rework. We can't let that happen, and automation is the only way we can address that. I always say, and I just tweeted this out the other day because I mentioned it to a customer, at some point, you must automate not only to continue to improve your process, but even to stay afloat in your process. You've got to automate to keep the ball rolling if you're doing things in a continual manner. Second is virtualization. Virtualization is about getting away from using physical platforms and physical environments that have to be set up each time and manually configured on the box with no ability to tear down and set things up in an automated manner. whether you're using the cloud or not. All right, and I know for some people that's more easy than others. We have some customers, they're completely in the cloud, everything from their development to their test environments to their production environments. We have other customers who, because they've invested in data centers and equipment and other things and test labs, a lot of what they have is physical. All right, you can use DevOps and automate your processes around integration and deployment and delivery into environments and automated test, whether you're in the cloud or you're on physical machines in the data center. If you use virtualization, a means of creating a virtual environment that you can put your software in, test it, and then make it go away and automate that process of provisioning those machines, putting your software on and configuring it, running what you want, and then letting it and making it go away. You have to virtualize to make this work. The benefits of it are simple. First of all, if you can virtualize the machines you have access to, whether they're physical or in the cloud, it significantly reduces setup and teardown times for your environments and for your testing. And let's be honest, a lot of the slowdown and impacts that we have when we're trying to test software has to do with setup and teardown. All right, whether that's between tests or at the beginning of test runs or the end of test runs, that's a significant amount of time. And if we could not only be able to do that in a virtual manner, but then automate that so we can do it at the push of a button, it saves us a lot of time and it's also repeatable, and we reduce the human error associated with it. It enables us to do essentially what I'm describing is infrastructure as code. So now everything is a script. Everything that we set up is a script. And it's set up and we mitigate the errors over time so that eventually we don't have any problems. And we know when we press the button that the test environment that gets set up is going to be exactly like it was the last time we used it and set it up. This also lets us make every environment over time look more like production. All right, and we get a lot of pushback from traditional software development shops about this concept. I'm a big believer, and we're big believers at Calveris, that everything from your different environments, the local environments your developers use, whether physical or in the cloud, should be as production-like as possible. Why? Because no more of this, well, it worked on my machine, right? I don't know why it doesn't work in the test lab. It worked fine for me. And usually when you get down to it, that's a configuration, or it's how the test environment looks more like production than the developer machines, et cetera, et cetera. Once you get virtualization established and you start thinking creatively about how to make systems look production-like, you can take that a lot farther than you would originally consider without a lot of cost. Now, I'm not saying that you're going to have access to all the equipment and all the infrastructure that you need and that you're going to use in your deployed production environment, that's all going to be available to your testers and your developers. But let's be honest, a lot of times, a lot of the other stuff beyond maybe your load balancer and some other things that you have that are expensive and are things that you can't easily replicate are available, and you can at least find the majority of the issues you're going to have downstream earlier in the process, which is the whole goal. The third, and now we're starting to get into some of the interpersonal cultural issues, is collaboration. All right, one of the things that we see a lot when we come in and people are struggling with Agile is they've embraced some set of ceremonies, stand-ups, sprint planning, Kanban board, retrospectives, et cetera, but fundamentally their developers and testers in their day-to-day lives don't work together. They're still doing little mini waterfalls inside their sprints. And as we just talked about with the issue of the Russian doll, that's not going to work very well because the handoffs between dev and test are just going to become too fast and furious as our software grows for that to actually work. We have to fundamentally change the way we work. I use a helix, which is on the right here, to describe how I think about how everybody on a team should be working together during sprints or during whatever the definition of the small pieces of work, iterations that you're actually doing. Each of the large strands is a different role. So maybe one strand is a set of developers or a developer, another strand is a tester. Maybe you've got a UI, UX person in there, a BA, whatever they are, each big strand is a role. And those roles weave around and intersect at various places. They intersect every day if you're doing daily stand-ups or daily huddles. They intersect at sprint planning and kickoff. They intersect at user acceptance tests and retrospectives. So the roles intersect, all intersect at certain times. However, in between that, we're not off in space, not dealing with each other. These small strands that you show connecting the roles, if you will, demonstrate that continually we need to have people working together and solving problems as a team. And I'm a big fan of doing that through pairing. There's a lot of talk about pair programming. Pair programming is nice. We've done pair programming. We like pair programming. We don't necessarily advocate or demand that everybody pair 24/7, but you could spend hours talking about pair programming and pros and cons and how to best utilize it for you. What I like, though, which isn't often talked about, is what I call pair dev test, right? Pairing a developer and a tester who are responsible for the building and testing of a story to work together. If you're doing test-driven development, acceptance test-driven development, BDD, anything where we are specifying what's going to get built, partially through examples and tests, then you want your developers and testers thinking through that specification up front. You want them reviewing each other's work, the tester making sure that the developer is thinking through good unit tests for what they're developing, that the developer is running and successfully executing the tests that are created that meet the acceptance criteria, that the developer is looking over the tester's approach to making sure that those stories are finished and they integrate properly using their knowledge of the design and how this thing is put together, and they're working together to collaborate and help each other. I find when you put a developer and a tester together and they're working together on a story and they learn how to help each other, that the collaboration goes through the roof in terms of what's possible on a team. Now, being agile, and I got to mention this perpetual motion machine here on the right because I think it's really funny. So it's an attempt at making a perpetual motion machine that drives itself like a car, right? And you see on the left are two magnets. There's an anvil magnet sitting on the platform, and there's a U-shaped magnet attached to a spinning wheel, a spinning gear. And the idea was these are two magnets that they don't attract. What's it called? They distract, and the magnet on the far left spins as it tries to pull away from the anvil magnet. That turns a crank, which turns the wheel, and the car goes by itself. Wow, that's cool. I wish it worked, but it doesn't. So I always like to say that in Agile and continuous everything, instead of asking the question why, for years we always asked, why are we doing this? Why do we really need to do this? The idea was, how do I make more efficiently? How do I cut down the number of tests that I have to do? How do I make my environment simpler? Why do we do things? The new paradigm is, why not? Once we have automation and virtualization and we're working together, why don't we do things? Why don't we run all of our regression tests if I can set them up automatically in the cloud and let them run and it doesn't cost me more than, let's say 4 cents, right? Which is about what the cloud costs these days to do anything significant, right? Why not push production-like environments to all the developers if we can virtualize that and it's all seamlessly built and delivered to them when they need it? Why not run things in parallel? Maybe our builds. Why not do our builds in parallel? If we have continuous integration set up and our build system is set up, that it's really easy to do that. If that speeds up our compilation process and gives us faster feedback. Why not check our code in regularly? If every check-in results in releasable code that finds downstream problems, why wouldn't we do that? Why wouldn't we do performance testing in our sprints now that we have production-like environments and we can at least start to figure out whether and find performance issues early in the process instead of getting late in the process and finding out we missed something? And why even wait till the evening to run our regression tests? Why not spawn them every hour for what's been checked in and integrated in the last hour and let it go off and run in the cloud or in some environment I'm not using and give me some feedback if it doesn't cost me a lot? So the paradigm is shifted from, I say, from why to why not. So let's talk about how you can get started in doing these kinds of things. And I'm going to talk about 5 things, and then we'll wrap up and do Q&A for those that are interested. So the first has to do with optimizing your process. First of all, your process, the first thing you ought to do with your delivery process, your build, your test, your deployment process, is document it. Lay it out and look at it, right? Even if it's manual. Figure out what the steps are. Now, how do you get from a change in the code through to something that's releasable? What does that process look like? How long does it take? How many steps are in that process? Who's involved in that process? How many sign-offs and check-offs are you? That will tell you the current state of your process. And your goal is going to be to shrink that, right? To release that so you're doing things on a more continual basis. You're going to do that by figuring out what are the constraints. Why does it take 3 months to get through that process, for instance? Why is it we can't put releasable code into production any quicker than 3 months? What you'll find is there's constraints in the process that are reducing the throughput, right? Some of these constraints that you often see might be that you have too much work in progress. So you're trying to do too many things at once, and because of that, certain critical things don't get done as fast as they could, and things that are not as critical do. Second is there might be wait time. So there's particular people you're stuck behind, or processes you're stuck behind, or sign-offs that you're stuck behind, that all sorts of work is queuing up, and because only one person can do it, and they're slow or never around or not available or whatever, overworked, that things just queue up. The third might be your process just might be wrong. It might just need to be reorganized, and you look at it and you say, well, there's things in here that we don't even need. That step there never bounces anything back, so why are we even it? If you haven't read the Phoenix Project, which is a book on DevOps, and it's a story-based book, and I highly recommend it, go out and get it, because it talks about this concept of how do you optimize your process, how do you think about constraints, and how do you reduce the wait times and the things you have to make your delivery process more efficient. Whether you're automated or not, you should do that. It will help your continuous everything. The second is start to improve your automation. Where do you start? Well, if you're looking to try to integrate and improve your delivery process, I always advocate getting your continuous integration capability up and running. That means automating your build and your test process. All right? Start with check-in builds. Start with something simple. Get your developers to incorporate unit testing into the check-ins. Static code analysis, other things that you can do quickly and simply with tools to check and validate and find problems as soon as things get checked in. All right, get that going. I'm surprised today how many people we talk to in organizations that still don't have a good automated build process, and they're not checking code in on a regular basis. And oh, by the way, a regular basis doesn't mean once a day. It means multiple times an hour often, all right? Maybe not that often, but as often as you can do it, and automation is the key to making that work. Automate and set up one test environment. Pick one environment that you can virtualize and automate and set up. Look for one environment where the cost of setup and teardown is the highest, and figure out how can I automate that process so I can do as much of that with a push of a button as possible. If you're not familiar with tools like Puppet and Chef and virtualization, virtual machines, that are out there, containers, things like that. Look into those types of things because they provide you capability to start to do those things, to set up your test environments in a more automated manner. The third is start to think about testing below the user interface. Now, we do a lot of testing at Coveris through the web UI using Selenium and other tools like that, but there's some very nice BDD, behavioral-driven development, test-driven development tools out there like Cucumber and others that will ease the process of doing things below the user interface. This is critical usually early on in a project where your UI is changing a lot, and it's very easy to create brittle tests that are automated through your UI that break all the time because you're constantly changing what you're doing. Now, we have some training in those areas to help people through those problems and build tests that aren't as brittle even when working through the UI, but there's a lot of value you can get from moving underneath the user interface, working at the API level and other places that don't tend to change, and means your tests are more testable and they don't break as much. Next is improving your environments. So make all environments as close as possible to production. As I mentioned earlier, it doesn't need to be perfect, but don't give up on it and say, oh, it can't be done. Because you'd be amazed how often we've heard that from customers who have said, we can't make our environments production-like, and we've marched ahead and made them very production-like. Get away from thinking it has to be perfect. You know, if you're 80% of the way there, you're going to find a majority of the problems that you're going to find later in the life cycle, and you're going to find them when they're quicker and cheaper to fix. It's worth that investment to do. Push environments to teams. Don't let developers and testers maintain and create their own environments. Now, some people are going to say, that's heresy, right? You need to own your own machine. You need to own your own environment. Well, unfortunately, people tend to put things on the machines. People tend to reconfigure them or change them, and a lot of times the problems that we find in test are due to things that were unique on the development boxes that are not production-like and are not the same as our testing environments. We've got to reduce those kinds of problems because that debugging time is a waste of time. So we have a number of customers who are defining a standard development environment and capability, and then those environments get pushed to each new member of the team that comes on, and they are pre-configured and set up automatically to be production-like so that any testing and development that's done, we have confidence is being done in an environment that looks as much as possible like the testing environments and ultimately the production environment that the code's going to see. This allows us to move assurance activities earlier in the process. You'd be surprised how many problems the developer can find before they check in the code, any new code that they've created. It reduces the variations and variabilities that we have to think about for test. It often reduces the number of tests that we have to do. It gives us higher confidence in delivery and makes sure that we're ready to deliver every time we check in new code. One of the fascinating things you'll find in your process is that a lot of times tests are rerun later in the process, and they might take days or even weeks to do. And when you ask, well, why are you running these tests? We ran them earlier. They'll give you all sorts of reasons, but typically they all boil down to one thing. They don't trust that the environment you ran the tests in are the same as the environment that they're running the tests in, and so they want to rerun them all. All right, we've had good experience over time when we've seen that situation, working with the teams to understand and see as we deliver good working software to them downstream that you don't need to redo those things. You can trust our environments like you trust your environments and reorient your activities to those things that are unique and different, say in a staging pre-production environment as opposed to a QA or a test environment. Improving your teams. So a lot of people get stuck doing what I call doing Agile, right? I do Agile. I do stand-ups, I do kickoff, I do Scrum, I do Kanban, I do extreme programming, I do Agile. One of the things I always emphasize in our fundamentals course is I think that's the wrong approach. We need to concentrate on the principles of Agile. The principles of Agile don't say I need to do any specific activity. It says these are the principles that what I do need to meet. And you should always be comparing what you're doing with the principles to convince yourself that what you're doing is Agile, because the principles do describe what Agile actually is. Concentrate on the principles to improve what you're doing. Don't do things because some Agile framework blindly tells you that's what you should do. Because in Agile, what makes sense for you to do is deliver working code that your customers are happy with, right? That's what Agile says you must do. Everything else is just a means to that end, and don't forget that. I am a big fan of retrospectives, whether that's what you call them or postmortems or whatever. You're not going to improve unless you're reflecting. Think about what you do well, what you don't do well, and make sure when you identify changes you want to make or things you want to try to make things better, that you actually do them. This is where a good project manager or a scrum master in Scrum comes in, and their weight is, is worth gold. To making sure that what the team says it needs to improve upon, the team actually then goes forward and improves upon. A lot of times when we come in, teams are struggling. One of the root causes is that they understand and they're pointing out things that aren't working in their retrospectives, but they're not doing anything about it to make it better. Fix that. Focus on controlling technical debt. There's great tools out there that can be integrated right into your continuous integration environment, so they run automatically, things like Sonar and Sonar Cube, that will allow you to measure how much technical debt am I piling up. For those of you not familiar with that term, technical debt is just the things about your code and about your tests and about anything you've built that isn't maintainable and supportable, isn't finished, is hacked together, is kludged, that later on is going to cost you money to fix. And the more you let that pile up, the more likely it is that you're going to have maintenance and support issues, and that's going to result in challenges later on down the road. We actually had a customer who their technical debt was so high, and they let it grow for over 8 years without addressing it, that they had to shut down all new development and spend a year re-architecting the product from scratch, because their customers told them, don't send me a new release because I don't trust that what you send me is going to work. You don't want to get in that situation. It costs them tens of millions of dollars to do. And last but not least, sustainable pace. So Agile says we shouldn't be killing ourselves every day. Yes, we're going to focus, we're going to work hard, we're going to do our thing, but we shouldn't be killing ourselves every day. Now, one thing that people often misunderstand is that doesn't mean in a particular sprint or at a particular time, crunch time, you're not going to have to roll up your sleeves and work really, really hard, all right, and spend extra time and effort. But I always say that as long as that's the exception, instead of the rule, you're okay. But when not doing things in a sustainable manner, killing yourself, death march, right, we would call it in software, that's not acceptable. Now it's become that unacceptable pace has become the rule instead of the exception, and you have a problem. You have to push back and fight against that, because teams that follow an unsustainable pace, studies show, make many more bugs. It actually doesn't get done any quicker. If anything, it probably goes slower. And they pile up rework and technical debt that just bites you in the butt down the road. So, last but not least, and then I'll take some questions with the time we have, is you need to find a champion. And this is someone up the chain who's going to evangelize and support your Agile efforts. I always say it's providing air cover for change, right? As you move to Agile, one of the things that organizations often forget and often don't realize is that Agile's going to touch everything. Because it's about customer and customer value and working differently with a customer, everybody to some extent in the org gets pulled into it. Sales, marketing, product management, product ownership, project development, operations, customer support, HR, they all get pulled in. And a lot of times they're not expecting to have to change or be involved in this process because it was orchestrated by a team or a group like software development or test, and nobody around them realizes this is going on until all of a sudden people are showing up and asking them to do things that they traditionally haven't done. You need to have air cover, and you need to have an enterprise view of Agile and making sure everybody understands what it means to move toward Agile. It'll help remove impediments for your progress that are outside of your team but might be slowing your team down. So with that, I know we're almost out of time. I want to thank everybody and answer any questions that have popped up anyone wants to talk about.
Thank you very much for that, Jeff. I just have one or two slides to go through here before we have a look at your questions. And just while I have you all here, I just want to make you aware of tomorrow's webinar. It's with Paco Hope, and he will be presenting on the topic of the 3 top techniques for web security testing using a proxy. And if you go to the EuroSTAR website as well, you can find out about our 20% pre-launch discount. There's more details there when you click on the site. And also by visiting our site, you will find out about our one-day software testing event taking place in Warsaw on April 27th. And that'll feature keynotes by Ruth Tunison, Rob Lambert, John Foda, and there's also going to be talks then as well by Alexandra Kasapu, Dorothy Graham, Declan O'Riordan, and as well as some Polish sessions with Michael Strajak and Radoslav Smilgan. I hope I haven't left anybody out there. So finally, let's have a look at some of the questions that have come through here. The first question I have for you here, Jeff, asks, releasing software becomes a business decision, not a technical one. Is this always the case for every industry? And I can go on a bit further as well. They've also...
No, that's an interesting question. I would say that... Hello?
Yep, sorry, Jeff. They have a second part to that there. If you want me to further explain their point, they were saying that surely healthcare and defense companies won't make a business decision until a technical one has been made. For example, testing has been signed off on. Yeah.
So I would argue that, I mean, the purpose of software is to support the business. So, obviously, it's a business decision when we release. Now, that doesn't mean the business can't decide that the decision is we're going to release continuously, right? There are certainly markets that release software on a constant basis to their developers, and they can do that because the cost of failure of any given release is very low. And in their business, it makes perfect business decision, and it is a business decision that we're going to put software out constantly and subject our customers to it. As you mentioned, there are other industries where you couldn't fathom doing that because either they're mission critical or there's regulatory issues associated with it, or we're in a business where our customers just accept change that fast, right? So I would argue it's always a business decision, but I'm not implying in that regard that necessarily means that it takes a long time to release or deploy software. Some businesses will make the decision they can do it very quickly, even every hour, if not every day.
Okay, the next question I have here is regarding the collaboration. And they say, what happens in maintenance mode post-release when some parties have moved on to other projects?
Oh yeah, the old maintenance versus new development challenge, right? So this is something you have to think through in terms of how you're going to deal with it, okay? And there's a bunch of different ways you can deal with it. I've seen teams that have essentially been split between people who are doing new development while some of the team members are responsible for maintenance and support. They're all in the same team, and they fill those roles for some period of time, and then they rotate. So you're constantly rotating people through the maintenance and support aspect but they roll back around to being new development, and they use that as a way to keep people fresh, but also keep people to understand, what issues and challenges customers are having with the software. I know a lot of companies have a completely separate operations and maintenance and support team as well. And some people feel that works best for them, and they keep those things completely separate. One point that you make, which is a common challenge in any model, is that when issues are found in production and first line, second line, third line of customer support can't solve those issues, or nobody is knowledgeable enough about the applications in those areas to deal with it, it's eventually going to trickle back down to somebody who's on to something else to deal with. And it's one of the reasons why I'm a big advocate of cycling people through maintenance and support, because your maintenance and support personnel have to be good, right? They can't be just fixing the basic simple things. They have to understand the product well enough to be able to fix more complicated things, and that typically means they need to have been involved in, or on some sort of a regular basis, be involved in new development as well.
And we'll take one more question, Jeff. That's okay. We've kind of run a bit over time, so we'll just have room for one more. And the last question.
Anybody that wants can also send me. You can send me questions to my Twitter.
Yes, absolutely.
Feed as well, and I'll answer them.
Right. And this question here asks, how do you effectively deal with unfinished features while maintaining a good continuous integration practice?
Wow, boy, we could spend a long time on that question. Yeah, so you're getting into really branching and merging and features, and how you manage those and deal with those. If you send me that question, I'll send you a couple links to things that will probably give you some good, interesting ideas about how to manage and deal with that. Branch merge strategy and integrating with continuous integration is a whole topic in and of itself. There are ways to deal with it, but you're going to have to be careful. That's what it boils down to. And you'll hear people say that it doesn't make sense ever to have feature branches. You should always just tag and turn on and turn off capabilities. There's pros and cons to every approach, and you really got to think through what you're doing and what's going to work for your team, and also what software you're using to manage and control those configurations.
And there's one or two people there as well, Jeff, asking about your Twitter handle here. And if I'm correct, it's at Jeffrey E. Payne. Is that correct?
Yeah, it's Jefffery E. Payne.
Okay, I'm just going to send that around to you all there so you all have it.
Yeah, it's on the first slide as well. So if you download my my slide deck, it's on the first slide.
Okay. And there we go. Sorry, I've been a little distracted there. I've sent it around to you all. And that's all we have time for today. Just want to thank you all for coming along. I see we've people from all over the globe again. There's people from Malaysia, Hong Kong, Portugal, teams tuning in from the States, which is great, and a few people closer to home up there in Northern Ireland. I want to thank as well our presenter today, Jeff, for his presentation. It was great, and a recording of this presentation will be available on the Test Huddle website very shortly. So that's all we have time for. Take care, and join us tomorrow for another webinar with Paco Hope. Take care. Bye now.
Thanks, Darryl.